Mr. Schumacher is the founder, CEO, president, and a member of the board of directors of Pressure Biosciences, Inc. Prior to PBI, Mr. Schumacher was the founder, president, and CEO and member of the board of directors of Boston Biomedica, Inc., where he built from scratch the world's preeminent quality control company for infectious disease testing. Mr. Schumacher?
Thank you. I want to remind everybody that some of what I'm about to say could be considered forward-looking statements, so please do your homework if you decide to invest in our company. I'm very honored to have the ability to present today a very, very enabling, exciting technology that we call pressure cycling technology. Some of the key investment highlights of Pressure Biosciences: we are focused on developing a technology that's powerful, enabling. We've got 24 issued patents. It's called pressure cycling technology, or PCT. In its simplest definition, what we do is we take pulses of pressure and we control how molecules work in the scientific lab. We know that pressure has been used for years to control how molecules work, speed them up, slow them down, kill viruses, things like that. We've gone a bit further. We use pulses of pressure. We filed and received 24 patents. We have more patents that are coming, we believe, all in the area of using pulses of pressure to control how those molecules work. And you think about the laboratory in the past several centuries, you think about scientists that are using temperature. They're using heat to speed things up. They're using cold to slow things down. You think about even when you go to the supermarket, you put your food in the refrigerator to slow down the bacteria growth. You use chemicals to change things. We use heat, cold, chemicals, but we also use it in a pressure chamber. We put the molecules, the cells, under pressure, and we control what happens to that cell by using different levels of pressure. We use pressures that equal 3 to 4 times the pressure you have at the bottom of the deepest part of the ocean. You think of the Marianas Trench, 6 miles down, 17,000 pounds per square inch. We can go to 17,000 to 34,000 to 58,000 pounds per square inch in a matter of seconds. And everything in nature has a pressure point. Everything has a pressure point. Once you dial into our machine and say, I want to go to X amount of pressure, I want to hold it for a period of time, and I want to cycle it 10, 20, 30 times, you can control what that molecule does exquisitely, much better than what the competition does. So the sample preparation is the area we're focused in. Think about the molecular age. We're studying proteins, lipids. We're studying not just proteins, but the things that make up proteins, the amino acids. We're studying DNA and RNA and the things that make up nucleic acid called nucleotides. We're studying these. We're at the molecular age. To study them, you need to get the DNA out of the cell. You need to get the lipid or the protein. Cells are made up of hundreds, if not thousands, of proteins. You need to get these proteins out of the cell to study them. Our job as a company is to use this enabling technology as a new way of breaking up a cell to release proteins, to release DNA, so that the scientists can study it. That's the main thing we're doing with this amazing technology. We think it's a very large market. We think it's about $6 billion, this sample preparation. People, you go to a restaurant, somebody prepared the food. You go home, somebody prepared the food. You go into a laboratory, somebody's preparing the samples to be analyzed. And that sample preparation often includes breaking up and taking out things from your sample, piece of skin, a tick, a blood sample, whatever it is. It often includes a number of things you have to do. We have brought to bear a brand new technology, something that's very different than anything on the market, pulses of pressure. It's a very attractive market that we're into because it's very large. We have 3 instruments. We have over a dozen consumables. We have over a dozen different applications now. We've placed 235 instruments in the last 5 years, mostly in the U.S. We have over 150 customers, and you'll see the list. Very proud of the list of customers we have. And it is a razor blade story. We sell the instrument that generates the pressure, and we sell the consumables that you put your skin, your samples into, your bacteria, your cell slurry, whatever it is, into the tubes that go into the pressure chamber. We're a company of about 10 people. We've got a very strong management team and board of directors. I'll show names very briefly, but you need to go please to the website and read about the CVs of these incredible people that I've been able to bring to bear on this technology. As we said, very strong IP. We do have some sales. Our sales are starting to ramp. We've said this for the last year. We've been working on this technology for 6 or 7 years. We started to sell it maybe before its time. We were getting a lot of feedback from our customers. Bottom line is we've reduced our burn by selling this instrument. Our sales from 2011 of $988,000 went to $1.2 million in 2012. The projections from at least one analyst out there is pretty aggressive, saying we should do $1.6 million in 2013, and I'll tell you right now, we are comfortable with that projection. We are comfortable with that projection of over a 30 or 35% increase in revenue. We feel that we are ready for prime time at this point. Our first quarter compared $371,000 compared to $306,000 in the first quarter of 2011. Going down to the capitalization table, we have about 18.5 million shares outstanding, fully diluted. If you look at all warrants, all stock, all preferred, all common, that's in the money. 18.5. The stock traded at 34 cents yesterday, about a 6.3 million market cap. We do have 13 million warrants and options. I will say there isn't a single warrant or option under 40 cents. Every warrant and option we have is between 40 cents and $3. Average price of our warrants, our options, is close to $1, and we have very few warrants that are actually even registered. So when these warrants are converted, there's going to be a 6 to 12 month holding period. So we think we have a really pristine capital structure for the investor. I've started 3 companies, Boston Biomedica, or co-founded. I founded Boston Biomedica, grew it to 300 people. Panicos Pharmaceutical, a very successful anti-AIDS company in the mid-2000s, 2006, 7. I was a co-founder in Trinity Biotech. I was in the founding group. Please go to the website and take a look at this incredible group of people. I do have Conrad Meir here in the back. If you raise your hand, Conrad is our CFO, and I have Kevin Pollack. Kevin is on our board of directors, so we'll be happy to see people at the breakout session or later tonight. Value proposition, we think, is pretty clear. The analysis of molecules, of DNA, RNA, proteins, lipids, and other molecules is absolutely essential to developing new drugs, new therapeutics, new vaccines, and better diagnostics. We have got to get these molecules out of the cell. How do we do it? We do it the way we've done it, that I did it in the 70s. We use mechanical means. We chop it up. We take the cells and we take a hammer and chisel and we beat the heck out of that cell. We take little beads that we spin around, boom, 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 and beat the cell up. We take blades and homogenizers like your blender at home and we blend it together. We use pulses of pressure. Think about our technology such as squeezing a sponge. The cell is the sponge, and we squeeze that sponge and we squeeze things out. And the papers on our website, over 100 papers on our website, many of them are most of them talking about the advantages of our technology over the mechanical means, and they're talking about things such as finding proteins that they have never gotten out of some cells before using the means that we've been using for a number of years. So the value proposition, again, is very, very clear. To develop new drugs, new cures, to prevent diseases, to develop better diagnostics, we've got to get the molecules out of the cell and get them out better, and that's what we believe we do. If I had one slide, this is a slide I'd show. Basically, what you see is a cell. Think about this cell as any type of normal cell, a cancer cell. It can be a bacteria, a virus. This is made up of DNA, RNA, but it's got thousands of proteins. It's got lipid. We need to break this up so that we can look at all the individual parts of that cell. It could be one part. You see this one protein here. It has 15 nodules. If this one protein with 15 nodules only has 14 nodules, that protein can make the difference, perhaps, between what anti-cancer agent can bind to the cancer cell or not bind. Personalized medicine at its top. So what we have to do is we have to be able to get the parts, what we call the biomolecules, out of the cell. We got to get them out in a form that we can test, and we've got to make sure we get as many out as we can. And that's what we do for a living. We believe we have a new way of breaking open cells and getting this rich list of biomolecules out in a fashion that's better than what's out there now. This is a $1 million machine in the middle. This machine's called a mass spectrometer. It's about $1 million. They run between a couple $100,000 and $1.5 million. This one's about $1 million. This mass spectrometer can read a protein and tell you what makes up the protein, tell you all of the things that make up the protein. But it doesn't matter. If you put garbage into it, you're going to get garbage out of it. If you break open the cell in a way that you destroy the protein or you don't get the protein out, you're not going to get the answer that you need. You're not going to win that Nobel Prize. You're not going to find that billion-dollar molecule. So quality of how you break open a cell, quality of how you start is very important. These are the mechanical means that I talked about. We all use mortar and pestle. Remember this in high school, chemistry class, 10th or 11th grade. We took a piece of skin from a rat, or we took a seed and we crushed it with mortar and pestle. They're still using mortar and pestle today to break open things. And as I said, we're using little beads to bang away at it. What we've done is we've taken the mechanical out and we've built in Mother Nature. We pulse it. Pulses of pressure. We squeeze that sponge. And by squeezing the sponge, we feel we get as much as the other guys get, what our competition gets, but we have also got papers on our website that say proteins they've never seen before are coming out by squeezing the cell through pulses of pressure. We also have ways of getting out DNA, RNA, and lipids. We have 3 different instruments that are out there now. We have a number of consumables. We've been building this system for about 6 years. We put about $40 million into this system, and as I've said on some recent talks, we believe we're now ready for prime time. Even though we do slightly more than $1 million a year for the last 3 or 4 years in sales, we've been doing it without a sales team, without a marketing team. We have 1 person in the field. We have 1 person back in the office of our 10. We're mainly immunologists and engineers and protein chemists, but now we're ready for prime time. We believe we now have what we need to get this product moving. You can see some of our 150 customers. We've got some very well-named pharmaceutical companies. These are companies that have published, hospitals, research centers have published, government agencies have published. These are groups that have bought the system and are using the system and are publishing. I'm not going to go through this, but this gives you an idea. This can be confusing. You look at all of these multiple applications of this technology. It's like owning electricity 150 years ago and saying, what do I do with it? We own 24 patents that say if we pulse pressure, if we put a sample, a mosquito, blood, a virus inside of a tube and put it inside of our pressure chamber, close the lid, tell the computer to pressurize it to some pressure and then turn it on and off, on and off, on and off. It can do multiple things. The important thing, and this is what our customers are doing, they are developing the applications. They're the ones like on the Apple iPhone that developed 300,000 applications in the first year. They're developing applications by buying our system and then figuring out what pressures to go to and how long to hold them under pressure to get the results that they want. We, as a company of 10 people, are focused in 2 areas. We're focused in biomarker discovery. We're focused in looking for things that will tell us that there is a disease there or there is not a disease there. And we're also focused in the area of forensics. And again, going to the website, all of these fine scientists have published and talked about the advantages. Dr. Hubble is one of the best in the world at looking at proteins through a procedure called EPR. And Dr. Hubble has said that he believes that pressure and using pressure, high pressure, is going to play a crucial role in studying and developing drugs in the future and studying proteins. And also Dr. Lee, who is is probably the foremost forensic scientist in the world, has also got a system because, again, it can be used for discovering biomarkers. It can be used in the area of forensics. We get more DNA out of bone. When you squeeze the bone with pressure, you squeeze more DNA out than you do using the methods that they use now. And there's other papers in the area of forensics. Recent news, I won't go through it other than please go to the website. There's a lot of news that's happened, particularly in the last few months. I'm going to go through 3 things in particular. One has to do with the financial situation of the company, and then 2 of them have to do with what we consider a breakthrough in our technology by being able to now do what we call high throughput, multiple samples simultaneously. So in the first one, on June 14th, we sent out a press release that said we had closed on a $2 million private placement that we had open, that we had raised money on over the past 6 or 8 months. We finished that. Our goal was $2 million. We did slightly more than $2 million. It was done at 40 cents a share. The majority of the time, the stock was between 16 cents and 35 cents. We closed it. All of it was done at 40 cents a share. and we did not register the warrants. The warrants are also at 40 cents a share. We also signed a convertible debenture several weeks ago. What we wanted to do was get our house in order for a couple of months as we do the second step. We talked about this fiscal roadmap at the conference call after the first quarter numbers, and also in the press release. We wanted to raise some money right away. The second thing is to look at some type of a bridge that would get us where we need to get to really commercialize and take advantage of these breakthroughs. And then down the road, when it makes sense, when we hope the stock will respond to all of this good news, we would look at financing the company like we haven't done before with a very large amount of money. The breakthrough technologies, these are the things I really want to look at because I want to try to connect the dots a little bit. Two things that we released in the last 6 weeks. Number one was the group at Harvard, that's the peace sign, but peace is like this. I think he's telling me I got 3 minutes. The lipid analysis work done by Dr. Crystal and his group at Harvard Medical School and the Brigham and Women's Hospital. They basically looked at fecal material from premature babies and newborns, and they found lipids, full lipids in this fecal material that had not been seen in fecal material before. And what they said in their publication, again, the publication is the link to it is on our website, is they now want to look at relating the lipid, the quantity of lipid, and the fact that that lipid is there to a disease of the GI tract. So you're looking at a non-invasive way of trying to find out what's going on in a preemie or a newborn all the way to the elderly. Non-invasive way of looking at fecal material, looking at lipids and fecal material using our procedure, our instrument, our consumables, and some chemicals that they've come up with. Combine them, and they're looking at finding lipids that they haven't found before, and now relating this back to disease of the gut. The second one is the larger breakthrough because it's happening now, and that's our core technology. We have all along, if you see this tube, our system is based upon putting samples in tubes. We put samples in either one large tube or multiple small tubes. You can run 16 or 48 small tubes at one time, but you have to open up and add to every tube one at a time. And we still sold 235 systems because people are willing to do it for that extra. Now, what we've been trying to do for 4 years and what we have done, the breakthrough that happened that we announced 2 weeks ago, is the entire world of science works in this area of microplates, micro-well plates or multi-well plates, where you have strips of 8, you can see strips of 8, and there's 96 wells. Every well is a sample. And you run anywhere from 8 to 96 at a time. And you do this by using a robot, because the robot has an arm that'll pick up and move the plate along. It'll add to everything and it'll wash everything. Well, we have these individual. We've been talking to potential partners for 3 or 4 years. What the partners have said is, we are all micro-well driven. You are single tube driven. We understand all of the advantages of your technology. When you have the micro-well technology, come back, because we want your advantages. So what I'm saying here now, what we said in our press release 2 weeks ago, is we had to find plastics that don't exist in the world today in the micro-well. We had to find plastics that could be molded into strips that could withstand the pressures and temperatures and chemicals that we add, and we also had to change our system so that it would take these strips, and we have done that. So now we are in the age of being able to do micro-well testing. Now we can do anywhere from 8 to 48 at a time. We are building this system as we speak. We put this in the press release. We are building systems for beta sites that have already been chosen. The beta sites are going to be running the micro-well strips. We're going to be looking at what's called high throughput. No longer will the customer, now some customers like to do 1 and 5 and 10 at a time. Other customers want to do multiple. They want to do strips. So what we're going to be able to offer them in the very near future is the ability to do strips. We are building the systems. We are going to our beta sites in October. We will have our data by December, and we will be selling this system in the first quarter of next year. We have spent millions of dollars, and we spent years developing this, and we are there. We have now got it. So the last slide I have to sum it up is, again, the beta site testing on our multi-well. Everything we have now will continue. There are laboratories that are more than willing to do 1 and 5 samples at a time because they don't have the large volume. But the bulk of the volume, where the big consumable orders come from, could never use our system. Now we hope, starting next year, they will be using our system. So now we also have the ability to go to potential partners and say, we can integrate with your system downstream. No longer are you going to have to go to your customer and say, well, do 1 at a time times 10, and then go back to your robot. Now, starting next year, we're going to be able to say, we can fit into your robot. You'll have your cake and eat it too. If you have a small amount of samples, you can do it through the tubes. The revenue we've been generating and the revenue that's been ramping is all based on our small sample. None of this is in our revenue model for this year, but for next year, on top of everything we're doing now, we will have the ability to do micro-well testing, and we are going to certainly focus on the non-invasive fecal testing for preemies, newborns, elderly, and everybody in between. Thank you very much.